I'm just in Maya here and I'm going to introduce a few of the concepts we've been looking at in terms of vectors. So the first thing is that we're using Cartesian coordinates, which is just numbers on the plane which indicate the location of a particular point relative to the origin, which is 0, 0, right in the middle here. In Maya, we use a right-handed axis system, which really only affects the x-axis. It means that it's going negative in this direction and positive towards me, so negative away from me, positive towards me. Our y-axis is going up vertically from here and down underneath the plane, so up in the positive and down in the negative directions. And our x-axis is across here, so that's going positive in the to the right and negative to the left here. So we have to keep in mind that we're using a right-handed axis system because it will impact how we figure out some of our calculations and rotations. So I'm just going on to look at vector addition and subtraction. So what I'm first going to look at here is actually just going to move this or get rid of it. So I have a couple of vectors worked out here. So I have the vector a and b, and I'm going to add b plus a. So how I would do that is I'm going to duplicate my vector a and just put it at the end of vector b here. So it starts where b ends. So if I was walking along b and then walking along a, that's b plus a. And it gives me this vector, which is our new vector d. So I'll just have this on so I have it done here on the script editor as well. So a is the point we can see at -4, -6, and b is the point 7 and -3. So when we add those together, we get the new point d, which is just the first component of a plus the first component of b, and the second component of a plus the second component of b. So I'll just print out the answer there and we'll just see if it matches what we've got. So so we have 3 and -9, and that's our point d. Now I'm just going to move this vector. If I wanted to do b minus a, minus a is the same as a, just in the opposite direction. It's a vector going in the opposite direction. So we're putting that to the other end of b here. So we're walking along b this way now and going minus a down here, and we come to e. So then e is similar, but just it's not going to be commutative. So we're going to put the b first, minus the a, and then b minus a again. So the order matters here. So we just print that out and we get 11 and 3. Perfect. So now if I wanted to find, we can just take that away because that's just a copy. If I wanted to find the magnitude of this vector, the length of this vector, because it has a direction and it also has a magnitude. So the magnitude of it is just each of the components squared and then the square root of that. So the square root of each of the components squared. So we have that done up here. So b squared equals the first component squared, the second component squared, and then we're trying to get the square root of that. So we can just print out that and we get 7.615, etc. So that is the magnitude of our vector b. Now, our unit vector is any vector with the magnitude of 1. So in this case, it's each component of the vector b divided by 7.615, etc. So then that gives us this point, which we can see, if we look at its world position, is 0.92 and minus 0.39. So that's our unit vector just from the origin to that point here. That's the unit vector of the vector b. I'm going to look at the dot product next. So the dot product is a multiplication of two vectors, which returns a scalar product. So it's going to be scalar A multiplied by, vector A multiplied by vector B. So vector A, so it can be done in two ways. We can multiply the magnitude of vector A times the magnitude of vector B times the angle in between them, and that will return a scalar answer, which is the dot product. Or, as I've done in this example, we can multiply A by B by multiplying the x component of A and the x component of B by the y, or the z in this case, but the second component of A and the second component of B. So we have that here, so I'll just print out that answer. I'll just input it first and then I'll print it out. And we get 48. So the dot product of these two vectors is 48. So I'm going to discuss the cross product now. I'm just using a very simple example with unit vectors here. So I have 2 points, point A, you can kind of see here, and point B. And A is a unit vector in the z direction, so its coordinates are 0, 0, 1. B is a unit vector in the x direction, so its coordinates are 1, 0, 0. And I'm going to show how we can multiply these to get a vector product. So when you multiply two vectors using the cross product, we get a third vector, which is perpendicular to both as our answer. And as you can see from this diagram, I have two perpendicular vectors. So the other thing that's really important about the cross product is that order matters. It's not commutative, so commutative even. So A cross B is not the same as B cross A. So how you do it is a little bit long-winded, but we look at pairs of components. So for example, with my y and z components, or with my y and z first, I'm going to multiply those out to give me my x prime, so my new x component. So I'm going to multiply the 0, so the y component of A, times the z component of B, which is another 0, minus the 1, which is the z component of A, times 0, which is the y component of B. That's going to give me 0. And then to get the y prime component of our new vector, I'm going to take z and x. Z first and then x. And I'm going to do the same. I'm going to multiply the z component of A times the x component of B, minus the x component of B, the x component of A times the z component of B. And that will give me 1, because in this computation it's 1, 1 minus 0 times 0. And finally, I'm going to multiply out my x and y's to give my z component. So I am multiplying the x component of A by the y component, by the y component, by the x component, by the y component of B and the y component of of A times the x component of B to give me Z prime. So it's so those, when they're all added out, give me the 3 points 0, 1 and 0, which give me my new vector here, 0, 1 and 0. And the only difference when I cross B cross A is that my vector is going to be pointing in the opposite direction. So it's going in the minus direction. And that's because when I change the order, I get 0, minus 1, 0 as my new vector. And so those are my two new vectors that I'd get from A cross B and from B cross A.